Hi children, welcome to Vidilakshmi YouTube channel. Today we are going to discuss about the topic part 4 electricity, resistance and on what factor does resistance of a conducting material depends upon. So first, what is meant by resistance? So last class we read about the Ohm's law. So in that we got it as V is equal to IR. So we stated then R is equal to V by I, and we mentioned this R means resistance. R is something called as a resistance, right? So what is meant by resistance? It is a property of material or conducting material which opposes the flow of current. So what is meant by resistance? It is a property of a conducting material which opposes the flow of current. So what is the formula? From that formula, V is equal to IR. If I need R alone means how I can rearrange the equation. So R is equal to V. Here I is in multiplication. While coming to the other side, it will become as a division over here. So R is equal to V by I, where R is a resistance, V is a potential difference and I is the current. So by using this formula, we can calculate the resistance of the conducting material. So next one, unit. So what will be the unit of resistance? Already we said the formula R is equal to V by I. So what is the V means already we said that potential difference. What is the unit of potential difference? A unit of potential difference is volt. And here I it is it. I represents current. What is the unit of current? The unit of current is ampere. So R is equal to volt by ampere, or else we can write it as ohm, or you can write it as a ohm, and this symbol will be saying it as a omega, and the symbol we are using in order to represent the unit of resistance, ohm. So next one we need to know on what are the factors does resistance depends upon. So the resistance depends upon the length of the conducting material. The resistance depends upon the area of cross section, and the resistance depends upon the nature of the material. On these three factors the resistance depends upon. So what is the first one? Resistance depends upon the length of the conducting material, resistance depends upon the area of cross section, and resistance depends upon the nature of the material. So let's discuss one by one. So first, already we said that resistance depends upon length. So how it is going to depend? Resistance is directly proportional to the length of the conducting material. Directly proportional means what? If one quantity is increasing, the other quantity also will increase. If one quantity is decreasing, the other quantity also is going to decrease, right? So here what are the two quantities we are taking? We are taking the two quantities. One is a resistance and another one is the length of the conducting material, right? So then if the length of the conducting material is increased, so what will happen to the resistance of the conducting material? The resistance of the conducting material also will get increased. Why? Because both are directly proportional to each other. If the length of the conducting material is decreased, the resistance of the conducting material also will get decreased. So here what is here? Resistance of the conducting material will increase. When it will increase? If I am increasing the length of the conducting material. So likewise, the resistance of the conducting material will decrease if we are decreasing the length of the conducting material. So this is our first quantity it depends upon. What is the second factor it depends upon? It depends upon the area of cross section. Area of cross section. So what is meant by area of cross section? If you are taking a wire like this, so already we know that this will be the from this point to this point we will be calling it as the length of the conducting material. So here one region is there, no? So this region is considered as the area of cross section of a conducting material. So how the resistance is going to depend upon the area of cross section? Resistance is inversely proportional to the area of cross section. What is meant by inversely proportional? If one quantity is increased, the other quantity will decrease. If one quantity is increased, the other quantity will decrease. Likewise, if one quantity is decreasing, the other quantity automatically it will increase. So here what are the two quantities? One is the area of cross section. If I am increasing the area of cross section, what will happen to the resistance? The resistance will decrease. Clear? If area of cross section of a conducting metal is increased, the resistance of the conducting material will get decreased. So suppose if I am decreasing the area of cross section, what will happen to the resistance of the conducting material? The resistance of the conducting material will get increased. Same as it is, the resistance of the conducting material will decrease. When it will get decreased? If we are increasing the area of cross section. If area of cross section has been increased. Likewise, the resistance of the conducting material will increase. When it will increase? If I am decreasing the area of cross section. So these are the two factors. Next factor is then nature of material. Resistance depends upon the nature of material. So how it is going to depend? For example, if you are taking a conductor and insulator, both are different natures, right? Conductors will allow the current to pass through them, whereas insulator, it won't allow the current to pass through them. Why? Because conductor will offer less resistance. So if the resistance, already know the formula, V is equal to IR. So you can say that I is inversely proportional to R. If resistance of the material is more, it will allow less amount of current. Why? Because both are inversely proportional to each other. If resistance is less, then it will allow the current to pass through them, right? So here conductor is offering less resistance. That means what is going to happen? It is going to allow the current to pass through them. Whereas insulator, it is having more resistance, right? Since the resistance is more, it does not allow the current to pass through them. If you are taking different materials, whereas if you are taking a copper and aluminum, each material will be having a different resistance value. So copper will allow a certain amount of current, whereas aluminum will allow a certain amount of current over there, right? And next, so here we are, based upon this one, we will be getting a certain problems. So already we said that resistance depends upon the length. So the R is directly proportional to L. And the second factor is resistance is inversely proportional to area. So the R is inversely proportional to 1 by E. So this one you can take it as equation number 1 and this we can take it as equation number 2. So now what you are going to do? We are just going to combine the two equations. So then combining the equation 1 and 2, we will be getting it as R is directly proportional to length and inversely proportional to area. R is directly proportional to length and inversely proportional to area. If you are multiplying L into 1, we will be getting it as L, right? And here in the denominator we are having, just assume here 1 is A. So 1 into A, we will be getting it as A over here. So R is directly proportional to length and inversely proportional to area. So while we are removing the proportionality symbol and we are going to introduce a constant. So this constant will be calling it as rho. So the symbol, how we will need to pronounce this one? This one you need to pronounce it as rho. And what does this one represent? This one represents the electrical resistivity, or simply we can call it as a resistivity. Again, we will just revise how we got the formula. R is equal to rho L by A. So we know that the first equation is R is directly proportional to length and second equation is R is inversely proportional to area. So what are you going to do? We are going to compare the two equations. R is directly proportional to length into 1 by area will be there. Here in the denominator nothing is there, so you can just assume it as 1 over here. So L into 1 will become as L and 1 into A will become as A. So the R is directly proportional to length and 1 by, that is inversely proportional to area. So now what you are going to do? We are going to remove the proportionality symbol and you are going to introduce one constant. So that gives an R is equal to, so rho L by A. So by using this formula, we can calculate the resistance as well as resistivity of the conducting material. So what is the final formula we obtained? We obtained it as R is equal to rho L by A. Suppose in the question if they ask us to calculate rho means what we can do? We are just going to rearrange the equation. So how I can rearrange? Rho is equal to, here A is in division. While coming to the other side, it will become as multiplication. You know that, right? Here L is in multiplication. While coming to the other side, it will become as division. So by using this formula, we can calculate the resistivity, and by using this formula, we can calculate the resistance of the conducting material if length and area and resistivity has been given out. So what does mean by resistivity? Clear? So resistivity final formula what you obtained over here, rho is equal to R A by L. So by using this formula itself, we can define the resistivity. So how we can define the resistivity? Resistivity is defined as the resistance of the conducting material per unit length with the unit area of cross section. Clear? How we can define the resistivity? Resistivity defined as resistance of the conducting material per unit length with the unit area of cross section, that will be calling it as resistivity rho. Rho is equal to R A by L. So what will be the unit of resistivity? So how we can derive that one? So rho is equal to R A by L, where R stands for resistance. R stands for resistance. So what is the unit of resistance? The unit of resistance is ohm. And then what are you having next to quantity? We are having A is A. What is A? A means it represents area of cross section. Area of cross section. What is the unit of area of cross section? We know that area is something called as a length into breadth will be calling, right? The same only, it will be there. Meter into meter will be there. So meter square will be there. Area of cross section unit is meter square. And what is the third quantity we are having in this formula? We are having L. So what is it L represents? L represents the length of the conducting material. So what is the unit of length? The unit of length is meter. So if you are substituting all the things over here, so what is the final formula we are having? Rho is equal to R A by L. In place of R, we are going to substitute as ohm. Why? Because R means resistance, the unit of resistance is ohm. And in place of area, we are going to substitute as meter square. A stands for area, so meter square. In place of length, we are going to substitute as meter. We know that meter square is nothing but called as meter into meter. So then I can cancel one m over here and another m over here. So remaining what will be then? So the remaining thing that will be equal. I'll just write over here. So a rho unit of resistance is remaining what is then? Ohm into meter. So this one will be the unit of electrical resistivity, or else you can call it as a resistivity. Yeah, okay students, I think the concept will be clear, right? Please subscribe, share and share with your friends. Thank you.